All right, welcome to lesson 9.3 on rotations. The learning target is I can identify rotations and perform them about the origin with correct notation. I will warn you, you can probably already tell that this lesson tends to be slightly longer. Often I'll do the definitions on like a short Wednesday and then do the actual lesson on a Thursday and then have some review time after that. So just kind of be prepared. This tends to be one of the trickier lessons in the unit. And I hope that we'll have some time to kind of go over it together if you need any help, or for sure make sure that you reach out to me if you have any questions, because this one can be kind of tricky when we're in person, and I think even trickier when I'm not there to kind of physically put my hands on your paper and move stuff around. So just be prepared, and please reach out for some help if you need. So the definition of a rotation is pretty obvious. It's just when we rotating a figure is spinning the figure a certain number of degrees about a set point called the center of rotation. So basically, anytime we rotate something, it has to rotate around a specific point. So sometimes the center of rotation will be on the interior or the inside of a figure when it moves. Sometimes the point of rotation can actually be on the outside of the figure. So we'll see it both ways, just like we saw with the line of reflection yesterday, that it could reflect kind of far away, or it could even reflect over itself. So you'll see it both ways. Okay, so here's some kind of silly, cute little emoji rotations. You don't need to write this down if you're taking notes, but it may be useful to just draw an arrow about how far each shape is spinning. And you may have seen these types of rotations before, but just want to make sure we're all on the same page. We can rotate clockwise or counterclockwise, but most of the rotations we are going to do are going to be counterclockwise, which means if you think about a clock, right, 1 through 12, an analog clock, um, the we're going to be going backwards, right, from the normal clock. So kind of the 12 through 1, so we're going to the left rather than to the right. So if you watch this first rotation, it's actually counterclockwise. So that's a 360-degree rotation. Means that we rotate it all the way around, right? If you ever hear people talk about like, oh, that's full 360, it means they go all the way around, right? Most common rotations are 90 degrees, which is like one turn, 180, and then there's your 270. So basically if you think about the 4 quadrants on a graph, right, each quadrant is 90 degrees. So 360 is flipping it all the way around. A 90-degree rotation is one turn, right, 1/4 turn around a center. 180 is turning all the way upside down, obviously, from our emoji, and 270 is 3/4 of the way. The notation that we use for rotation, it's a little tricky because we did have a capital R for reflection, so we have to kind of pay attention. Rotations uses a lowercase r, and that's just so that we can tell the difference between them. So we use a lowercase r to say that we're rotating. The first, we are going to have kind of, it looks like the x comma y notation we have for translations, but the first number that goes there is going to be degrees, right? So are we rotating at 90 degrees or 100 degrees or 180 degrees or 270 or whatever? And then right here, the next number or letter is going to be the center of the rotation. We are always going to rotate around the origin when we're on the coordinate plane. So when we're going to do off the grid rotations in just a minute, which we may rotate around a different point. But when we're on the XY axis, just to keep things simple, we are always going to stick to the origin. Okay, so there are ways where you can do kind of some fancier rotations around different points, and maybe I'll find some videos about that to share with you guys. But what you guys need to know is the origin. So here are some of our off the grid rotations, which means that we are not using a coordinate XY graph or axis. We're just kind of looking at some points on a piece of paper or on the screen. It asks us to name the image of the point under a counterclockwise rotation about C. So that means that we are going to the left, right? So in the opposite direction that a clock would go. C is the center of the shape, which means that because it's in the very center, all of these lines are going to be congruent to each other. And then because it's an equilateral triangle, all of these sides are going to be congruent to each other, obviously. So if you notice, we have 3 triangles in there that are actually congruent by side, side, side. So we have, let me see if I can highlight this without messing everything up. We have a triangle here, we have a triangle here, and we have a triangle here, all 3 of which are congruent by side, 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 which means by CPCTC, haven't heard that one in a while, that all of the angles on the inside of the triangle kind of surrounding that center are going to be congruent. Okay, so just want to make sure we're kind of all on the same page. that those three are congruent. So when it asks us to find the image of M under 120-degree rotation, well, M is right here, right? We know that C is our center and we want to rotate around the center. So let's figure out if we have 360 degrees, right, in our triangle, because it's a circle, it's a full all the way around 360, and we split that into three parts, 360 divided by 3 is 120. And so that means that each of these little pieces in here is going to be 120 degrees, right? They're all congruent, adds up to 360. So if I want to take M under 120-degree rotation and I'm rotating it counterclockwise or to the left, right from the top, then when I move it over, the image of M, when I've rotated it 120 degrees, is actually going to be over here at point D. So the image of M under 120 rotation is actually that point D. Okay. The image of D under a 240-degree rotation, well, 240 is just going to be like two 120-degree rotations. So if I start with, hang on here, if I start with D and I go 240, that means I'm going to go 120 and then 240. And so that means that going all the way around, the image of D is actually going to be the final piece here that it asks us is R120 and C, right? So basically that's telling us, okay, we are rotating point A, right? Here's our point that we're trying to start as our pre-image. We're going to rotate it 120 degrees around point C. So if I'm taking point A and I want to rotate it 120 degrees and we're defaulting to counterclockwise, I'm going to start at point A, rotate 120 degrees, and then I actually end up at point M again, okay? So those are called off-the-grid rotations. You'll see a few more of those in your homework assignment tonight, and as always, if you need any help with them, they can be kind of tricky. Let me know and I'll do my best to help. Okay, so this is a part that is an activity I usually do in class. It's going to take us probably a couple of minutes, and you'll probably want to pause several times throughout the lesson. You're going to need a piece of graph paper, or you're going to need to sketch out some kind of a graph in your notes. But go ahead and draw a rectangle with corners at A 2, 2, B 2, 5, C 6, 5, and D 6, 2. So pause, take a minute and do that. Should look like my blue rectangle here. And then you're going to need to sketch this table into your notes. So we're going to kind of do this off to the side and keep track of what our coordinates look like. So if you look up at the top here, we have the coordinates of our vertices. Okay, so we have A, B, C, and D. And I wrote down exactly what I had on the last slide. You can go back if you need to. And then we're going to do some rotation. So our first rotation where we're starting is like 0 degrees. Right? We haven't rotated it at all yet. It's just at the beginning. We're going to do a 90-degree rotation, a 180-degree rotation, and a 270-degree rotation. And we're going to fill in these points as we go. So get this sketched into your graph. Pause if you need to. All right, so here's where in class I usually walk around and help people physically turn their papers because this can be a little tricky. So I can only click through it once the way that my PowerPoint recording works, but please go back and rewatch each little section as you need to if you get kind of stuck so that you can see how to turn your paper. So the first step we're going to do is we're going to turn our graph, like literally take your notebook and turn it 90 degrees to the right. So watch this. Ta-da! So I usually in class will have students label where the top of their paper is, and as they go, I kind of have you match it up with where I have the top of my paper written right here. So right now, the top of your paper should be over on the right, and then you're going to draw the exact same rectangle again. So pretend for now that you can't see any of this down here. We're going to pretend that this is our y-axis and this is our x-axis, and we're going to go through and draw the exact same rectangle. So you should have something that looks like this. So you have your A prime, B prime, C prime, and D prime. And then we're going to turn our graph back so that it's back in its original position. Okay, so we have the top of the paper back at the top. So what you'll notice is even though we turned our paper to the right, we actually took our pre-image ABCD and we technically rotated it to the left or counterclockwise. So here's kind of the mind-blowing piece of this for a lot of students, is that in order to get a counterclockwise rotation, we actually have to shift our paper clockwise, and then it automatically does the counterclockwise rotations for us. If you need to go back and watch that part again, please do, because that's the part that gets people stuck pretty often. So now we're going to go and record the actual coordinates. So with our paper rotated back to the front, we're going to record the coordinates of A prime, B prime, C prime, and D prime in our table. So now you'll notice that my y and my x-axis are back to normal, if you will, right? They were the way they were when we started. So there's my y-axis and my x-axis, okay? So now I have my A prime at -2, +2, right? My B prime is at -6, +2. Go through and record those and pause if you need a minute. So take a look at the coordinates that I have and just compare them to what you have. So for the 90-degree rotation for A, I had -2, I already mentioned that. B, I had -5, +2. C, I had -5, +6. And D, I had -2, +6. So the question is, what pattern do you notice between the 0 and the 90-degree coordinates? Do you notice that we are actually, the first one is a little bit hard to tell, right? We just sort of have this negative popping up. But on B, do you notice that we actually take the X and we put it at the end in the Y position, and then we take the Y and we put it at the front in the X position, but we also pop a negative on the front there, right? So we basically take our X and our Y and we flip-flop it and make that first one negative. So that same pattern holds in C, right? We flip-flop our X and our Y and we make that first value negative. Same thing in D. We flip-flop our X and our Y and we make the first value negative. So we're going to repeat the process with a 180-degree rotation. So now instead of just turning a quarter turn counterclockwise, we're going to turn it all the way upside down so that the top of our paper is at the bottom of our paper now, right? So we flipped it upside down. So kind of match your paper up with mine. Draw in your points there. Take a minute and pause if you need to. So if you notice, I actually have used, so here I use regular prime notation. When we add another level of prime, we call it A double prime, B double prime. So you get up to, quadruple, quintuple primes. We're only going to get up to 3. But so now I've drawn my new shape. We're going to repeat the process and flip it back so that it's normal. So again, if you notice, we've actually taken our original shape and rotated it 180 degrees counterclockwise. The interesting thing about 180 is we could technically say it's going either way, right? We could make the argument that we actually went clockwise, but for the sake of our argument here, we're going to say that we're going counterclockwise for every rotation. So we've gone counterclockwise. Now we need to record our points. So please take a minute to write out your points in your graph. So right now that we have our y and our x kind of back to their normal positions, A prime would be -2, etc. Go through and write those points out. Pause if you need to. I'm going to go through my points. For 180 degrees, for A, I got -2, -2 again. For B, I got -2, -5. C, I got -6, -5. D, I got -6, -2. Okay. So my question is, what pattern do you notice between the 90-degree and the 180-degree coordinates? Okay. So take a look at how this one matches up to this one, how my 90-degree matches up with my 180 in each of them. You notice that there's actually a pretty similar pattern going on. I'm taking my points and I'm flip-flopping them and I'm making the first one negative again, right? In B, I took -5 and put it at the end. I took 2 and put it at the front and made it negative. Same thing in C, right? I flip-flop my points and make the first one negative. Okay, same thing in D. I flip-flop my points and I make the first one negative. So we're seeing some patterns here. Interesting thing about 180 degrees is actually we go from 0 to 180, we just make the points all negative, right? So if we started with negative points, we just change the signs on all of them and make them positive. So kind of cool thing about 180 degrees. So let's go ahead, you do the process for 270. So you're going to turn your graph 270 or 3/4 turns to the right. Draw the rectangle in the new top right quadrant, label the A, B, C, D points with 3 prime points now. Turn your graph paper back to normal and record the actual coordinates with the top at the top in your table. So pause because it's going to take you a minute to do that. So filling out our coordinates for the 270-degree rotation, for point A, I got 2 comma negative 2. For point B, I got 5 comma negative 2. For point C, I got 5 comma negative 6. And for point D, I got negative 2 comma 6. So go back through and double check, make sure that your points match up with mine, and make sure that your graph basically looks like you have 4 rectangles that have just been rotated around in a circle. So again, look at the points that are just one row above the 270. So that 180 row, a quarter turn before it, is that pattern we noticed before still holding where we flip the points. So if I take the first point, put it at the end, yep. Take the last point and put it at the beginning, we're not technically making it negative, or it doesn't look like it at least, but if I took negative 2 and made it negative, negative 2 actually does become positive 2. So I'm still flipping my points and making the first one negative. Same thing here. Am I flipping my points? Yes, from negative 2, negative 5 to negative 5, negative 2, and then we make that negative 5 positive, right? Or technically I'm making it negative, but negative 5 is positive 5. Right, same thing here. Negative 6 flips to the end, negative 5 flips to the front. Make it negative means we really make it positive, and we get the positive 5. Same thing here. Negative 6 flips over here, and then negative 2 flips to the front. So the question I'd ask you to think about, excuse me, for just a moment is, how are the coordinates of a particular point changing each time we rotate it 90 degrees, right? So I'm not asking you to go from 0 to 270 and write a pattern, or from 0 to 180 and write a pattern, although they exist. But just every time we rotate it 90 degrees, what's happening? Think about that for a minute. So the way I describe the pattern is that for every 90-degree rotation, and remember that we're always going counterclockwise and around the origin, we're starting with our XY point and we're flip-flopping X and Y, and then we're changing the sign of the new X coordinate, which we could also say is like the old Y coordinate, right? Because we took the Y and we moved it forward. So another way I like to write it is to write my original XY point here and then say, okay, what I really did is I took that Y and I put it at the beginning and made it negative. And then I took the X and just copy and pasted it into the end, right? So if I gave you this point, negative 2, 5, and I told you wherever it is on the graph, just do a 90-degree rotation to it counterclockwise, you know you're going to take the points and flip-flop them, and then you're going to make whatever that first new point is, you're going to make it negative, right? So you flip-flop it to 5, negative 2, and then just pop a negative onto the beginning there. So your assignment is page 565, and there are the numbers right there. I would ask you please to graph 17, 18, and 54 through 56 separately. There's several rotations that happen in the same graph, and typically I have students trying to graph like 5 graphs on the same, like 5 rotations on the same graph, and it's very unclear for me to look at. So please do the pre-image and image individually for each of those graphs. Remember to please use a straight edge and have nice straight clean lines. Use some graph paper, color your images, etc. One last note I would throw in here is that you don't technically need to know the patterns to do rotations. What I often do is I don't really think about the patterns. I just rotate my paper. I say, if I need a 270-degree rotation, I'm going to rotate my paper 3/4 turns, graph the new shape, and then rotate it back. So the rules are just kind of there to help you think through that there are patterns and there's connections between how we do these rotations. But for me personally, I'm very visual. It helps me to just do the actual turning of the paper. So again, if you need any help, please don't hesitate to reach out to me via email or Microsoft Teams, and we can set something up to go over some of the problems and help you figure it out. Thanks for watching.